All right, we're going to jump right into problem 8, and we're going to do parts 1 and 2, or A and B, or however you want to call it. There are 3 parts, but we'll just get to the first 2, and then we'll see if people are wanting me to do part 3. We'll see. But I kind of consider that one of the harder parts in the entire unit, and the math is not hard, but setting it up is the trick. So we are going to do problem 8, A and B. So first off, let's just set it up, and then I want you to pause the video and give it a try yourself. So we have, let's take green. So we have a Q1, a Q2, and a Q3. So we have Q1, Q2, and Q3. And it tells us a distance, although the distance it's not important at all for the first part, but we'll pencil it in here, part A. So the position of Q2 is, this distance is 0.312 meters, and Q3 is 0.169 meters. Okay, so that's the distance between these. So we don't know positive or negative for part A. They just want to say what if. Okay, so, excuse me, they want to know what is the force of Q2, the force on Q2, from its interaction with 3. Yes, 1 has some stuff to do with it, but right now these true-falses are just over what is 3 doing to 1. 3 doing to 1. Okay. With that being said, to the right if the charges have opposite signs. So let's just make a what if. What if they're both positive? What is 3 doing to 1? 3, like charges repel each other, so 3 is pushing 1 to the left. Yes, 3 is pushing 2 to the left. Yes, 2 is pushing 3 to the right, but they want to know what is 3 doing to 2. So what is 3 doing to 2? It is pushing, if they're like charges, they will push it. 3 is pushing 2 to the left. So they have, opposite signs. I'm sorry. Opposite signs. I said same sign. So strike that. One of them's negative and one of them's positive. It doesn't matter. The results are still the same. So if they're opposite charges, one is pulling it to the right here. So sorry about that. So if they're opposite charges, and likewise if this was a plus and this was a minus over here, what is 3 doing to a 2? It's still pulling it to the right. So that's why it is true. To the right. So, okay. To the right if the charges are negative. So if they're both negative, what if it's negative and negative? Okay, let's decide. Well, pause the video and see if you can get the next 4 parts. Just go ahead and give it a try. Alright, so if you didn't pause it, I waited a heartbeat and now we're back to it, but you can pause it and try to do this. So what if they're both negative? So if they're both negative, what is 3 doing to 2? This is 2, this is 3. 3 is pushing 2 to the left. So it says right here, that's why this one was false. So this was true, this is false. Okay. Left, if the 2 charges are positive. If they're both positive, the same thing's going to happen. Like charges repel each other, so it's going to push it to the left. And it says left, so true. Left if the 2 charges have opposite signs. Well, here's opposite signs, that's the same question. It's to the right, that's why it's false. To the left if the 2 charges are negative. Those are the same sign, so it's going to be just like this to the left, and that's why it is true. Okay. Now, pause the video if you haven't given B a try, and this is just like one of the other problems we did. You got to find what is happening to 2, and you give you the charges, you can put them up here, and then you can try it out and try to find the excuse me, the net force here. Alright, so let me erase this and we'll get this out of the way, and as you're erasing it you can be setting up your problem. I need more room. Okay, so there we go. I should have an easier way to do this, but I don't really know at this point. I guess I could have made it thicker, but I'm almost done, so we'll just move on here. Alright, here we go. Let's put the size of the charges on there. We have, it says Q1 is this, so 1.3 coulombs, and that's the correct charge for the formula we're going to use, Coulomb's law. This one is 3, negative 3.03 times 10 to the minus 6, and this one is 3, positive 3.03 times 10 to the minus 6, all coulombs, so we're good there. Now, we need the signs on these. We have positive, this is a positive, this is a positive, and this is a negative. That's very important for our direction. Okay, so first off, we need to find F1 to 2. What is 1 doing to 2? This Coulomb's law, okay. Q1, Q2, and the distance squared. Okay, so we put this in here. K is 8.99 times 10 to the 9th, and then we have this one and this one. You can put them in there. I'm going to run a room, so just fill in Q1 and Q2. Put positive signs in there, and then you fill in the 0.312 and you square it. So those guys right there go in there, so make sure you do that. And then when you get this, you get 0.4841 newtons. And then what is 3 doing to 2? Same thing, same formula. K, which is 8.99 times 10 to the 9th. And then Q2, which is negative 3, but I would just leave it as a positive and then deal with the sign in a little bit. Positive 3.03 times 10 to the negative 6. And another one for this one up here. Times 10 to the minus 6. The units are all fine, coulombs and meters again, I think I said that. 0.169, don't forget the squared. And when I do that, I get 2.8898 newtons. Okay, now we need direction with these. So, let me go back up here real quick. What is 1 doing to 2? They're opposite in sign, so isn't it pulling it this way? So we'll call this one negative here. That's a negative 0.4841 newtons. And what's 3 doing to 2? It's pulling it this way. So we'll call that a positive 2.8898 newtons. Okay, so what's the overall net result? You just add those two, you get 2.406 newtons, and that's the net force, and that's right there. So I encourage you to try these, and send me an email if you have problems.